Hello guys, shall we explore on the color of the compounds? Yes, just guess how the different fields are correlated in one particular concept, that is transition metals belonging to the D block elements in the periodic table. Let us recall some basic coordination terminologies before we start with crystal field theory. What are central metal atoms? Transition metals like copper 2 plus, cobalt 3 plus, Fe 2 plus. Ligands, Cn minus, F minus, water, ammonia. You can have both anionic and neutral ligands. Next, coordination number of ligands attached to the metal atom. It can be 4 or 6. If it is 4, tetrahedral or square planar. If it is 6, octahedral. Then the types of d-orbitals. There are 5 degenerate suborbitals: dxy, dyz, xz, dx square minus y square and dz square. For dxy, the lobes are in between the axes, and for dyz also the lobes are in between the axes. Then for dxz also the lobes are in between the axes. When the lobes are in between the axes, we say it is T2G level. Then the remaining dx square minus y square and dz square, the lobes are along the axis, we say it is E2G level. With these few terms, we go forward to the concept of crystal field theory. When the ligand which acts as point charges approaches the central metal atom, repulsion exists, leading to breaking of degenerate d orbitals. Let us consider an example: cobalt ammonia 6 3 plus system. These degenerate orbitals lose their energy and gets converted into non-degenerate level or activation energy of d orbital. After this, the electrons are filled in the T2G and Eg level with respect to their stabilization energy and pairing energy Pe. T2G level for octahedral complex has a stabilization energy of minus 2 by 5 del naught and Eg value of plus 3 by 5 del naught. The minus and plus sign indicates the decrease and increase in energy value. In specific, you should know how the electrons are filled in the system. For example, D6 system, weak field ligands are nothing but the Cl minus, F minus, Br minus, that is, which do not contain carbon, hydrogen, nitrogen and oxygen. And strong field ligands are the compounds containing carbon, hydrogen and nitrogen. In the case of weak field, del naught is less than Pe. Pe is nothing but pairing energy. Each orbital is singly occupied and then paired in the lower level itself. The unpaired electron 4 signifies it is paramagnetic and colored. In the case of strong field, del naught is greater than Pe, that is, electrons are filled in the lower orbital itself. No unpaired electrons, so it is diamagnetic and colorless. Hence, with the same idea, stabilization energy can be calculated for tetrahedral and square planar complex. From this stabilization value, wavelength of the compound can be calculated using the formula lambda is equal to Hc by del naught. So now you can find the magnetic moment of the compound plays a major role in the production of cosmetics, drugs and equipments. So I thank you for your patience listening. Hope you would have understand about the introduction of crystal field theory.